Hi, my name is Mirza Wahaj and I'm the training manager for Redline Communications. In this video, I'm going to present a technical overview of the RDL 3000 UHF system and discuss its configuration in operation in the FCC and non-FCC deployment domains. The title of this video is RDL 3000 UHF System Overview and Operation, and the content covered in it includes RDL 3000 UHF System Overview, RDL 3000 UHF System and the White Space Database interactions and messaging, configuring the RDL 3000 UHF system to use the White Space Database, and system parameters applicable to the White Space Database driven deployments of the RDL 3000 UHF system. The prerequisite for this video is the RDL 3000 basic link configuration video, which is available at this link. You must view this video and understand the following concepts very clearly: RDL 3000 point-to-multipoint and point-to-point wireless network operation, managing and configuring the RDL 3000 units, and subscriber link, group, and service functions in configuration. To begin with, it's important to define a few terms and terminologies that we shall use throughout the video. The first one is TV white spaces, abbreviated as TVWS. This refers to spectrum in the broadcast TV bands not being used by licensed services such as television broadcasting. In other words, TVWS refers to vacant TV spectrum made available for unlicensed use. The TV white space spectrum is located in the VHF and UHF bands. In the VHF band, it is from 54 to 216 MHz assigned to TV channels 2 to 13, while in the UHF band, it is from 470 to 698 MHz assigned to TV channels 14 to 51. The RDL 3000 UHF system supports the UHF band 470 to 698 MHz. The TV white space spectrum has certain characteristics that make it highly desirable for broadband wireless transmission. And these characteristics include excellent propagation, ability to penetrate buildings in foliage, and deployment at these frequencies do not require line-of-sight connectivity between a transmitter and a receiver. The second term to be defined here is TV bands devices, abbreviated as TVBD, and these are devices using the TV white space spectrum. FCC has divided these devices into fixed and personal portable devices. Fixed devices remain stationary and are limited to using 4 watts of EIRP only. Fixed devices cannot use the co-channel or adjacent channel of an active TV station when these devices are within the protected contour of the active TV station. However, fixed devices can use the second adjacent channel of an active TV station even when the devices are within the protected contour of the active TV station. Personal and portable devices are allowed to be mobile and they can use 100 milliwatts or 40 milliwatts of EIRP. Portable and personal devices are not further discussed in this video. The last term to define here is White Spaces Database, abbreviated as WSDB. WSDB is Ethernet based and maintains current status of all protected TV band users and include broadcast TV stations and radio observatories. This database determines the available channels at a specific geographical location and provides the list of available channels to a TVBD registered with it. Also, regular IP connectivity between a TVBD and a white space database is a must. This slide describes the overall TVBD deployment architecture and the white space database and TVBD connectivity. One of the fundamental elements in this architecture is the white space database, which is FCC certified. Therefore, all the rules and regulations that FCC wants a TVBD to follow are saved in this white space database. Spectrum Bridge is currently the white space database administrator that Redline devices use. Also, the TVB vendor, in this case Redline Communications, applies to FCC for registration and obtaining an FCC ID. Using the FCC ID and other applicable parameters, Redline Communications registers with the white space database and obtains in return the white space database credentials. The credentials include an authentication certificate and the URL for the white space database. The parameters returned from white space database to Redline are hard-coded in each Redline UHF system. From that point on, Redline enrolls each unit with the white space database as part of the order fulfillment. The device serial number and the RDL 3000 UHF system FCC ID are used to enroll the RDL 3000 UHF systems with the white space database. When deployed, both the TVBD master, in this case sector controller, and a TVBD client, in this case the RDL 3000 UHF subscriber, must access the white space database independently and obtain the list of available channels in their deployed locations. further rules and regulations to be followed by the TVBD master and TVBD client in the process of accessing the whitespace database and establishing an RF link are discussed in this video later on. Deployment of TV band devices are subject to FCC specified restrictions, including antenna height above ground (AGL), height above average terrain for the whole deployment, and the maximum EIRP that can be used by the system. The antenna height above ground is limited to 30 meters and is configured in each unit. In the RDL 3000 deployment, the AGL value is configured in both sector controller and a subscriber. The height above average terrain is limited to a maximum of 250 meters, and this parameter is calculated by the whitespace database from the input from the TVBD. If this value exceeds 250 meters for a particular deployment, registration of that TVBD is rejected by the whitespace database. The maximum EIRP for fixed devices are 4 watts or 36 dBm, and maximum EIRP is a calculated value. It is the TX power, that's the maximum TX power from this radio, minus the loss of the RF cable connecting the radio to the antenna, plus the gain of the antenna. The maximum TX power from each RF port in the RDL 3000 UHF system is 23 dBm. So total power from the system is 26 dBm, used for the purpose of calculating EIRP for the deployment. The RDL 3000 system operating in the frequency band from 470 to 698 MHz is by definition called RDL 3000 UHF system. UHF stands for ultra high frequency. This system uses radio type T072, and from FCC point of view, it is a fixed TVBD. When deployed in the United States of America, it must have an FCC specific options key and is using the Spectrum Bridge whitespace database. The RDL 3000 UHF system can be deployed in the whitespace database as well as non-whitespace database regulatory domains. The active options key in the product determines that capability. While with the FCC specific options key, it supports only 6 MHz channel size. In other countries, it is a simple RDL 3000 system operating at the license frequency of 470 to 698 MHz. The RDL 3000 UHF system is certified by FCC and Industry Canada. This is the FCC certificate, as you can see here. The FCC ID QC8 RDL 3000 RMF is used, and the device type is fixed type. It's also certified to operate in the frequency band 470 to 698 MHz. Here 473 to 695 MHz has been shown because the channel size supported in the US is 6 MHz. So the first usable frequency is 473 MHz and the last usable frequency is 695 MHz based on 6 MHz channel size. Similarly, this is the Industry Canada certificate, and it supports 512 to 608 MHz and 614 to 698 MHz frequency bands. The RDL 3000 UHF system product options key is region specific. Here I have two options keys, options key 1 and options key 2. Options key 2 is FCC specific. When this options key is enabled, you can see here the whitespace database control, which allows you to configure the applicable parameters, and the status we have the whitespace database status, which shows the channel list returned by the whitespace database to this particular unit. Similarly, as you can see here, the channel size is limited to only 6 MHz, and the RF frequency needs to be selected from the drop-down menu here. The options key is specific to Industry Canada, allows 6 and 12 MHz channel sizes. Options key 1 in this unit is the general options key, and when it's enabled, as you can see here, we don't have any whitespace database control here under wireless configuration, and there is no whitespace database status tab under the status page here. Similarly, as you can see here, there's a drop-down menu for the channel size. Channel size supported includes 3.5, 5, 7, 10, 14, and 20 MHz. Similarly, the frequency can be typed in the 470 to 698 MHz region. This slide describes parameters applicable to the FCC specific options key. When this options key is enabled, you can see the whitespace database control tab here. This will allow you to configure parameters in the unit that will enable it to access the whitespace database. You can see the whitespace database status tab here. This will show the list of the channels returned by the whitespace database to the unit. As you can see here, all the channels are flagged in red, which means these channels are not available. This is because you can see that the unit has not been able to access the whitespace database as yet. The FCC ID of the product is shown here. This is saved as part of the firmware in the unit. the whitespace database URL is saved in the unit. In my units here, I'm accessing the Spectrum Bridge demo database, not the actual database. So that's why I have this tvws-demo.spectrumbridge.com. In an actual production unit, this will be tvws.spectrumbridge.com. The location of the product is shown as a default 0000. This is because the product coordinates have not yet been configured in the whitespace database control page, or the GPS unit in the system is not active yet and has not been able to pick up the coordinates of the system. Through CLI, you can see the whitespace database authentication certificate saved in the product. This is actually the X509 type of certificate given by Spectrum Bridge to Redline, and Redline will save this in every unit. This will authenticate the RDL 3000 UHF system to the whitespace database. You can see it under Show Files Run. When the unit is able to access the whitespace database and is able to register successfully, the whitespace database returns the list of available channels. Some of the channels will be here in blue color, and those not allowed to be used are flagged in red. We can see this later on in this video. After enabling the applicable options key in a unit and verifying that the required product features have been enabled, it's important to configure the unit. Sector controller and subscriber stations have to be configured so that they are able to establish a wireless link and be able to access the whitespace database and obtain the list of available channels in their deployment locations. This screen shows the sector controller wireless configuration. The options key has limited the sector controller channel size to 6 MHz. This drop-down menu shows the list of channels enabled by the enabled options key. As you can see it here, from channel 14 all the way to channel 51. Channels that are prohibited are not shown in this drop-down menu. The sector controller can be configured on any of these channels. However, the sector controller will not be able to transmit on the selected channel before it can access the whitespace database and gets the list of available channels in its deployment location. Once the sector controller has contacted the whitespace database and has obtained the list of available channels, it will check if the selected channel is flagged as available. In this case, channel 32 selected on the sector controller is flagged as available. Therefore, the sector controller will start transmitting on this channel. When a channel is selected and is being used by the unit, it is flagged in green. If the channel was selected but was flagged unavailable by the whitespace database, the channel will be flagged in yellow here. If the sector controller selected channel is not available to be used in its deployment location, then the sector controller needs to be manually configured on one of the available channels. In this example, if channel 32 was not available, then the sector controller should be configured on one of these channels flagged in blue. The TX power of the sector controller should be configured to comply with the EIRP limit of 4 watts. The RDL 3000 UHF systems always have GPS deployed with them. If the GPS antenna is external, then the GPS antenna type should be selected as active. If the GPS antenna is integrated with the sector controller antenna, the GPS antenna type is passive. A similar configuration also applies to the subscriber. This is the wireless page of a subscriber station. The options key has enabled these channels from channel 14 all the way to channel 51. This unit has already contacted the whitespace database and has obtained the list of available channels. So these are the list of available channels. And you can see here that channel 20 has been configured. Let us assume the auto scan is off. In this case, the subscriber will try to link up with the sector controller on the channel 20. And when the list is received from the whitespace database, it will see if channel 20 or 509 MHz is flagged available by the whitespace database. If that is the case, the subscriber will continue to be linked up with the sector controller. If channel 20 is flagged as unavailable, the subscriber will suspend transmission. If auto scan is enabled, the subscriber station will scan all the available channels in order to find a sector controller. In this example, the subscriber has scanned the available channels to find a sector controller on channel 32. And the subscriber has linked up with the sector controller on channel 32, and that's why it is flagged in green here. You can see 581 MHz is the channel 32 frequency. The channel selection process in the subscriber station is discussed further in this video later on. In addition to configuring the wireless parameters in the sector controller and subscriber stations, DNS servers and the geolocation information of each unit must also be configured. 2 DNS servers can be configured for redundancy. The sector controller and subscriber stations will use the DNS servers to access the whitespace database. These DNS servers reside in the end user's network. Also, under the white space database control tab, the geolocation information of each unit must be configured. The system's latitude, longitude, antenna height, and other parameters must be configured correctly. The system can also pick up the LAN LAT value from the GPS if a GPS has been installed with the unit and the GPS is able to see enough number of satellites to be able to determine the LAN and LAT of the deployment. The information configured in this page, along with the information the system picks up from the firmware itself, is included in the registration message of the unit sent to the white space database. White space database will use the LAN LAT and the antenna height values to calculate the height above average terrain for the deployment and to make sure it is not exceeding the 250 meters specified by FCC. By default, the logging in each unit is set to level 0, which is the quiet mode. This doesn't basically record all details of the interactions between a unit and the white space database. However, for the installation period, it is highly recommended to set the log level to level 1 or the verbose mode. It can be done only through CLI, and the command is set white space database log level 1. Issuing the save command will save the log level to level 1, which is the verbose mode. But after the installation is complete, it is recommended to set the log level back to the default value or the quiet mode log level 0. This slide talks about subscriber provisioning. As mentioned earlier, the subscriber can access the white space database only through the wireless interface. The subscriber will first link up with the sector controller, and within 30 seconds of linking up with the sector controller, it will try to register with the white space database to obtain the list of available channels and its deployment location. If the subscriber is not able to access the white space database within 30 seconds of linking up with the sector controller, the subscriber will suspend transmission. It is therefore important that for each subscriber, provisioning parameters must be configured on the target sector controller. The provisioning parameters, as discussed in the basic RDL 3000 video, which we talked about as a prerequisite to this video in the beginning, includes a subscriber link definition, a service group, and a service. Service group and service definitions will allow the subscriber to send its registration message to the white space database through the sector controller and through the IP network here. In summary, I would like to emphasize that it is not possible for the subscriber to remain linked up with the sector controller if it is not able to access the white space database through the sector controller and register with the white space database and obtain the list of available channels. The subscriber Ethernet port may be connected to Ethernet, but the subscriber will not access the white space database through its Ethernet port. It will wait to register with the sector controller and then it will attempt registering with the white space database. This slide summarizes the process of obtaining the list of available channels from the white space database by the RDL 3000 sector controller and subscriber station. The process begins with the sector controller powering up. When a sector controller powers up, it will not transmit on its selected frequency. It will pick up the white space database URL from its firmware and sends it to the DNS server. The DNS server will return an IP address to which the sector controller will send a registration request. This registration request includes all the parameters required for the white space database to validate the sector controller. The registration request includes the sector controller's serial number and the Redline FCC ID, along with the GPS coordinates and other applicable parameters as discussed earlier. Once the white space database validates the sector controller and returns the registration success response, the sector controller will make a request to obtain the list of available channels in its deployment location. The white space database, based on the sector controller registration message, will determine what TV white space channels are available in the location of the sector controller and returns a list. Assuming the sector controller configured on a frequency and that frequency is available on the list of available channels returned by the white space database, the sector controller will start transmitting. The subscriber station will then locate the sector controller and will link up with the sector controller on the selected frequency. Once the subscriber station links up with the sector controller, it will start to build up a registration message and send it to the white space database in order to obtain the list of available channels and its deployment location. The process is the same as discussed earlier. The subscriber station picks up the URL of the white space database, sends it to the DNS server, and then sends a registration request and then receives the registration response. If the registration response is successful, then the subscriber will send request for the list of available channels. The messaging between the sector controller and the white space database, as well as the messaging between the subscriber and white space database, are shown in the sector and subscriber logs later on in this video. As mentioned earlier, the white space database is Internet-based, and therefore there must exist an active IP connection between the white space database and the RDL 3000 UHF system attempting to register with the white space database and obtain the list of available channels. As you can see here, the RDL 3000 unit fails to get access to the white space database. And the failure message reported here is DNS name resolution failure. The system will retry in 15 seconds again. This could happen because of a number of reasons. Most important of these reasons could be wrong DNS configuration. A DNS server is not available, or the DNS server IP address has changed, or the DNS server IP address has been configured wrong in the unit. The sector controller is shown here. So the sector controller has no IP connectivity with the white space database, or probably the sector controller has got the wrong IP address. The sector controller is not able to send the messages to the internet out of its own network. It is therefore important to make sure that the DNS prompters and other connectivity prompters in the sector controller and subscriber are configured properly. In the process of obtaining the list of available channels for their deployment areas, the sector controller and subscriber exchange many messages with the white space database. Assuming the log level was set to the verbose mode, let us see what are the messages exchanged. The sector controller on power up checks its own internal health here, as you can see, and then it starts messaging with the white space database. It opens the SSL connection to white space database and sends a registration request. In its registration request, the sector controller includes all the applicable prompters, including the Redline FCC ID and the unit serial number. As you can see, messages coming and going, and at last there is a message from the white space database, SBI-status 0. This means all messages from the sector controller were successful and the sector controller is registered. After that, the sector controller requests for the channel list from the white space database, and eventually the database sends 38 channels, and the list is from channel 2 all the way to channel 51. After the channel list is sent by the white space database, the channel refresh time is set. As you can see here, refresh time 48 hours, but actually the channel list is refreshed after 24 hours. When the channel list is refreshed after 24 hours, the expiry time is set to the next day midnight. Once the channel list is obtained from the white space database, the sector controller will check to see if its selected frequency is among the list of available frequencies. In this case, channel 32. This channel was pre-configured on the sector controller and is now available, so the sector controller starts transmitting on this channel. The channel selected and available is flagged in green. Based on the RF planning in place, the sector controller can be configured on any of the channels supported and flagged in blue. Channels flagged in red are not allowed to be used. Once the sector controller has started transmitting, the subscriber will start the ranging process, and eventually the subscriber registers with the sector controller, as you can see here. Although sector controller receives a list of available channels, no channel can be reserved by the sector controller. The white space database also, as you can see here, sets the refresh time and the channel list expiry time. If the sector controller's selected channel is flagged in red, which means it is not available to be used, then the sector controller has to be manually configured on one of these available frequencies. Through proper network planning, it must be ensured that the sector controller is not deployed in an exclusion zone. This slide describes the messaging between the RDL 3000 UHF subscriber and the white space database. Again, it is assumed that the subscriber log has been set to the verbose mode, as discussed earlier. On power up or reboot, the subscriber goes through its internal check and then links up with the sector controller on a selected frequency or on the frequency that it has found through the scanning process. After it has linked up with the sector controller, as you can see here, link ID 6, this is the MAC address of the sector controller with which the subscriber has linked up. The subscriber gets into the business of messaging or registration with the white space database and obtaining the list of available channels for its deployment location. Eventually, the white space database returns the list of available channels to the subscriber, as you can see it here. Channels not available or channels prohibited to be used are flagged in red. Channels available in the location of the subscribers are flagged in blue. In the channel selected by the subscriber and available is flagged in green. If this channel was selected by the subscriber and it is not available, this will be flagged in yellow. When the list of available channels come from the white space database, the subscriber will check to see if selected channel is among the list of available channels. If it is, then the subscriber will continue to remain linked up with the sector controller. If the channel selected for the subscriber is not among the list of available channels, then the subscriber will suspend transmission. This is further discussed in the next slide. The RF channel selection in the subscriber station can be manual or through the auto frequency scan. The subscriber can be configured on any of the channels enabled by the FCC specific options key, or the subscriber could be configured to use the auto frequency scan. Irrespective of the frequency selection method, the subscriber will locate the sector controller to begin with and will link up with it on either the configured frequency, or it will locate the sector controller through the frequency scan process and links up with it. As discussed earlier, within 30 seconds of linking up with the sector controller, the subscriber must register and obtain the list of available channels for its own deployment location. This is the list of available channels in the location of the subscriber returned by the white space database. As you can see here, the selected channel of the subscriber is among the available channels. However, subscriber is not able to link up with the sector on this particular frequency. Because auto frequency scan is on, this subscriber will scan channels flagged in blue till it locates a sector controller. In this case, the subscriber has located the sector controller or channel 32. If the subscriber's selected channel, that is channel 20 or 509 in this case, is flagged as red, meaning that this channel is not available in the location of the subscriber, then the subscriber will do the following two things. If it has no frequency scan enabled, the subscriber will cease transmission and will not attempt again for another hour. If the subscriber has auto scan enabled, it will as usual go to the scanning mode to find a frequency that's available and with which it can link with the sector controller. This slide describes how the subscriber reacts when its selected channel is not among the list of available channels as indicated by the white space database. As you can see, the subscriber starts in the normal way, checking its own parameters, linking up with the sector controller, and then starts messaging with the white space database. As you can see here, all the messages from the subscriber to the white space database and from the white space database to the subscriber have been all okay. After successful registration, the subscriber sends a request to the white space database for the list of available channels. The white space database sends a list to the subscriber, and the subscriber finds that its selected channel is not available in its deployment location. The subscriber suspends transmission for an hour and the link goes down. The TV white space channel usage is also subject to restrictions specified by FCC. A TV band device cannot reserve a channel. On losing connectivity with the white space database, a TV band device is allowed to continue operating but must cease transmitting no later than midnight the next day unless connectivity is restored. Operation on channel 36, 37 and 38 are restricted, which means these channels cannot be used and they are flagged in red when the list of available channels are returned from the white space database to a TV band device. This is an RDL 3000 UHF sector controller, and you can see that channel 36, 37, 38 are flagged in red. You may also note that there are channel 2 to channel 13, but RDL 3000 supports only channel 14 to channel 51. It's also interesting to see here that in the location of the sector controller specified by the GPS coordinates here, channel 18 is not available. Channel 32 is available and selected. Hover your mouse on it and it will tell you that. Let us see what happens to channel 18 when we go to the subscriber location. You can see here channel 18 is available in the subscriber location. The GPS coordinates of the sector controller and subscriber are different. But channel 36, 37 and 38 are flagged in red in the subscriber location as well. Frequencies for channels 35 and 39 are shifted by 500 kHz from channel 36 and 38. Channels 35 and 39 are also required to operate at a reduced maximum transmit power. FCC has also imposed restrictions on the validity of the available channel list. The TV white space channel list is available for up to 48 hours but is refreshed after 24 hours. The refresh timer is restarted for another 24 hours and the channel expiry timer is restarted to expire at midnight the next day. Midnight next day means next day 11:59 p.m. As you can see here, the channel refresh time and the channel expiry time are shown here. Channel needs to be refreshed after 17 hours 1 minute and 39 seconds. Similarly, the channel list will expire after 1 day 8 hours 14 minutes and 41 seconds. This slide shows a snapshot from an RDL 3000 UHF unit system log. As you can see, this unit received the channel list from the white space database on December 6th at 17:44:48, and the channel list refresh time was set to 48 hours. However, as discussed earlier, the channel list will be refreshed on 24-hourly basis. Now you can see that exactly after 24 hours, the channel list was refreshed on December 7th at 17:44:49. And from this point on, again, the channel list is refreshed within 24 hours. You can see the channel list came again on December 8th at the same time, 17:44:51. As mentioned earlier, if white space database connectivity is lost, radio will continue to operate until channel list expiry timer finally times out. Once the channel list has expired, the radio will stop transmission. Transactions between the Ordeal 3000 UHF system and the white space database, as well as warnings and errors, are written to the system log. That is in the logs of the Ordeal 3000 UHF systems. In order to see details of messaging between an Ordeal 3000 UHF system and the white space database, the logging in the Ordeal 3000 unit must be set to the verbose mode. As discussed earlier, the command is set white space database log level 1 and then issue the save configuration command. Without issuing this command, the log level will return to level 0, which is the quiet mode, if the system is rebooted or restarted in the process. After installation is complete, it is recommended to disable debug log feature, which means return the log level into the system to level 0 or quiet mode. The command is through CLI set white space database log level 0 and save configuration. It's also possible to configure a syslog in an Ordeal 3000 UHF system to send the logs in a syslog server. You can see here that a syslog has been defined in an Ordeal 3000 unit. And the Ordeal 3000 unit sends all logs to this syslog server. Messaging between the Ordeal 3000 UHF system and the white space database is initiated by the Ordeal 3000 system itself. The Ordeal 3000 unit sends a message to the white space database. The white space database evaluates the parameters in the Ordeal 3000 system message and returns a message status code. These status codes are from 0 to 254. Each status code refers to a particular error in the message that the Ordeal 3000 sent to the white space database. The first message sent by the Ordeal 3000 system to the white space database is the registration request. The Ordeal 3000 system wants to register with the white space database as discussed earlier. The database evaluates the parameters submitted by the Ordeal 3000 system and then returns a message. In this case, SBI-status 0. SBI stands for Spectrum Bridge, and status 0 means the message sent by the Ordeal 3000 system could be processed successfully and all parameters were correct. So that's why the Ordeal 3000 system is registered with the white space database. After registering with the white space database, the Ordeal 3000 system sends the channel list request. The white space database again evaluates the message to make sure everything is correct and returns a message status code. Again, status code 0, which means everything was fine. And based on this, the white space database returns the channel list to the Ordeal 3000 system. In this message here, as you can see, the message status code is 10, which means the antenna height was configured greater than 30 meters in the Ordeal 3000 unit. Similarly, you can see here that the white space database returns a message status 9, and this means that the location configured on the Ordeal 3000 unit is outside the FCC domain. It is therefore important to review the system logs to see what message errors have been reported by the white space database and make corrections in the configuration accordingly. This does it for the Ordeal 3000 UHF system overview and operation. If you have any questions, please send us an email at training@ordealcom.com and we shall get back to you at the earliest possible. Thanks for watching and bye-bye.